Okay, hello everyone. This is Dr. Gallenstein, and today I just want to provide a little bit of support using Stata to help you navigate your first assignment. So this is Stata Assignment 1, Part 1. Okay, and what I want to do in this demo is I want to open up Stata. I want to give you a little bit of an overview for using Stata if you haven't used it before, very briefly. And then I want to show you how to perform a randomization. Okay, how to randomly assign treatment and control groups in a data set in Stata, okay, because you'll be doing that on your homework, and so you need to know the code. You need to know how to do it in practice, and that's what this video is going to help you do. All right, we're going to go through it, talk it through, be really clear. So this will help a lot with your assignment. So let's do it. So I'm just going to open up the data set. Okay, here's our data set. You will be able to find your data set on Blackboard. You just download it from Blackboard, open it up in Stata. You can use a computer lab, or you can do Stata on your own computer if you have it on your own computer, which I recommend. Okay, so for those of you who have not opened or seen Stata before, I actually recommend that you take a look at my Stata tutorial video located on another location on my YouTube page under my Applied Econometrics course playlist. But for now, let me just do a quick overview. If this is your first time seeing Stata, when you open it up, when you click on that data set, Stata is going to open, and then you're going to see something that looks a little bit like this. Okay, what you'll see here in the middle is your output screen. This is where all of your results will show. This is where all of your commands, when you execute them, will be shown. Okay. Over here is a list of previous commands. I like to just keep that small because I never really look at it. Down here is a command window where I can type commands if I want. I rarely use it, so I usually keep it small. Over here you'll see a list of all the variables in your data set. So these are all the variables in our data set. This is the name of the variable. And then over here you'll find a label, and the label basically tells you what the variable is. So for example, NH, all right, the name of this variable is NH, the label is HHID. Now even that label might not be very clear, but I can tell you what it is. HH means household, and ID means identification. So this is an HHID, this is a household identification number. Every observation in our data set will be a household. In fact, I can give you some more background. This data set comes from Bangladesh. Okay, the data set that we're using in class is based on a real data set collected in Bangladesh in 1998. Now, I say based on because I took a real data set and then I made a bunch of changes and manipulations to it. So it's no longer a fully real data set. It's basically I've adapted it for instructional purposes. Okay, so you cannot use this data set for real analysis. This data set is only used for my class. Okay, I got the data set from the World Bank. It's publicly accessible data from the World Bank. I will give you some Stata codes in the future where you can find more information on where I got this particular data set. Okay, so the data set was collected from low-income farming households in Bangladesh. Okay, so there's a lot of variables in here related to household identification, just basic descriptive statistics of households, basic just variables from households that you might see in a farming context. So I go through here. VIL is a variable that indicates a village. It's a categorical variable. It's a unique village ID number. Okay. Age head means the age of the household head in years. Gender is the gender of the household head, where 1 equals male and 0 equals female. EDUC head, that's education of the household head in years. Fam size, that is the size of the household, the number of members in the household. HH land, that is the household land. That is how much land the household owns, measured in a units called decimals. HH asset, this is household total assets. FD, household per capita food expenditure. Exp NFD, household per capita non-food food expenditure. Exptat, household per capita total expenditure. This will be very important because this will be your outcome variable in your analysis. Okay, V access, this is village is accessible to road all year. PCIRR, proportion of village land irrigated. Rice, this is the price, the unit price of rice. Wheat is the village price of wheat, and egg is the village price of egg. Okay, so that is our data set. We can take a look at it. If we come up here and we look at these icons, we can click on this one. This will open up our data. This is our actual data. This is NH. That means this is a unique household identification number. Every household in our data set has a unique identification number. All right, if you've never looked at a data set before, I can talk about this for a minute. So when you're looking at a data set, what you'll see here is that each column represents a variable. Each row represents an observation. In our case, each observation is a household, so that means one is one household. That household is labeled with a unique identification number, 11054. Okay. And now, like I said, each column is a variable. So this is village, this is age, this is gender, this is education level, etc. So a variable takes on different values depending on what observation you have. So let's take this for example. Household number 1 is given the household ID number 11054. All right. They are from village 11. The age of their household head is 79. The gender of the household is male. The education number in years, the household head has never attended school. The family size is 2. There are only 2 members in the household. The household land size, they own 36 decimals of land. The household assets, the total number of assets, the total value of the household assets is $33,295. The expenditure on food per capita is $8,262. Okay, etc. And then these values, the value of the variable will be different for each observation. So for household number 2, the age of their household head is 43. There are 4 people living in the household. They have 116 decimals of land, etc. Okay, so this is our data set. Now, from the assignment, what we're saying is that this is a data set. So now we're getting into the assignment here. We're getting into the story of the assignment. In the story of the assignment, scenario 1, this is a data set that you have been given by a nonprofit organization that wants to implement microfinance. That means they want to provide loans to low-income households in hopes that those loans will help them to achieve higher incomes, okay, or higher expenditures. All right, now this is a data set that they collected before ever implementing their microfinance program, at least in this particular area. Okay, so we call this a baseline data set. This is a data set that includes information on the households, on a sample of households. Let's see how many. 1,129. All right. This contains a sample of 1,129 households collected from the target population. So the population of households that this NGO is looking to target, looking to help. Okay, so this is just information about these households. What we will do is use this information to randomly assign each household to either the treatment group or the control group. We need to randomly assign households to the treatment group and then the control group, where the treatment group will go on to receiving a microfinance loan and the control group will go on to not receiving a microfinance loan. And as long as these are randomly assigned, we will be able to compare them and look at the impact of the microfinance program on our outcome variable of interest. Okay, so that's what we're going to do today, is we're going to randomly assign these households to the treatment group and the control group. We are going to do the first stage in an experiment. All right, that's what this video is for, to illustrate how to go about doing that. All right, I'm going to close my data here now that we're introduced. I'm going to now open up a do file. All right, and in this do file, I'm going to go ahead and show you how to do this. All right, all right, so let's do it. Stata tutorial randomization. All right, so this is how we're going to do it. This is how we randomize. All right, so first, let's take the example of us wanting to randomize at the household level. All right, we're going to look at randomization at the household level. I might make a note of this. So let's see. Practice number 1, household level randomization without stratification. So no stratification. All right, we'll do that first, and then we'll do a randomization with stratification. All right, as we do this, I want to have the data set open. All right, I want to have the data set open because I think that will help us. It'll help us to understand what is happening. Okay, what I want to do is I want to create a new variable. I want to create a new variable. Okay, you'll see it over here. I want to create a new variable. Ultimately, what I want to do is create a new variable that will indicate whether or not a particular household is in the treatment group or the control group. So that means I want to create a dummy variable, a binary variable, where the variable equals 1 if they are in the treatment group, and it equals 0 if they are in the control group. Okay, that's what I ultimately want. But then how do I do that in practice? Well, in Stata, we need to kind of go through some steps to get to that point. I might make a note of this. We ultimately want a variable. Let's call it T group, and I'm still calling it T group. That stands for treatment group. Okay, I want a variable called T group. We ultimately want a variable called T group. All right. Now you'll notice if you haven't used Stata before, you'll notice here that all I'm doing is taking notes. If I use the little asterisks here, it turns my letters green, and if it's green, that means it's not a command. It's just there's just notes. You'll see more in a minute. All right. So we ultimately want a variable called T group, where T group. Let's see. Where T group will equal 1 if the household is assigned to the treatment group, and T group equal 0 if the household is assigned to the control group. All right, that's what I ultimately want. All right, but what's the first step? All right, the first step, and this is not immediately obvious, but the first step is going to be we want to do something called set the seed. All right, it's not obvious at all. Set seed 1, 2, 3, 4, 5, 6. All right, a little bit of background here. What Stata does when you randomize something is that Stata is going to draw numbers from a random number generator. And what you want to do is you want to tell Stata to draw numbers from a random number generator in the same way every time that you run that particular set of code. And in order to do that, you put set seed, and then you just type some number. It could be any number. I just like to do 1, 2, 3, 4, 5, 6. You don't need to understand that in detail, but if you know what I'm saying about a random number generator, you'll follow this. And if not, just understand that what we need to do is set the seed so that the random number generator will give us the same numbers every time we run this code. All right. Okay, so we do that first, and then we're going to generate a variable that will be a random number. Okay, we're going to generate a variable. When you want to generate a variable, you use the command gen. So gen, and we're going to call this randnum. All right, randnum. That's the name of our variable, and it is equal to uniform. All right, we're going to draw random numbers from a uniform distribution. And that's what this command does. Generate. We're going to generate a variable. That variable is going to be called randnum. It is equal to some random number generated from a uniform distribution. All right, so what we're going to do is we're going to run the code. If you run the code in Stata, you're going to highlight it. I'll close this now so you can see this happen. I'm going to highlight it and hit execute. Executes this button up here. You highlight the code you want to run, then you hit execute. You'll see that the code is now here and it has run. Stata ran the code. So let's open up our data set again and we'll find our new variable. Here's our new variable, rand_num. Every single value in this variable is going to be a random number drawn from a uniform distribution between 0 and 1. It is just some entirely random number. All right, and each individual household has a different random number generated from a uniform distribution. All right, now how does that help us? Well, the next step, what we want to do is we want to create another variable that's going to order, that's going to give us the ordering of those random numbers. All right. Again, this might not be obvious why we're doing this, but it'll become more clear in a minute. I'm going to create a variable called ordering. All right. I'm using the egen command. That's another command that allows me to create a variable. But this is the one that I use if I need to use a command in the definition of the variable. So I'm going to use egen ordering equals rank random number. All right. This command, what this is going to do, it's going to create another new variable that is equal to the ranking of the random number variable. All right, so let's click this and see what this looks like. Hope it's running. There it is. All right, so I just created a new variable called ordering. And what this does is it tells me the order from smallest to largest of the random number. Okay, so for example, the first household, their random number just came out to be 0.1799588, and that is the 211th smallest random number in the data set. The second household, they just got a random number of 0.7752 and so on. That is the 874th smallest smallest random number. So what this does is it creates a ranking. It just gives you the number, the order that these particular random numbers fall in. All right. Now, why is that helpful? Why am I doing that? Well, we're going to use this ordering variable to label households, to assign households to treatment and control group. Okay, so that's going to be the next step. What we're going to do now is we're going to generate our T group variable. This is the variable that we ultimately want to have. T group variable, we're going to say it equals 1. And then we're going to replace T group equals 0 if, and this is where we're going to use our ordering thing, if ordering is less than half. All right, I'm going to generate this and then I'm going to explain it. All right, here we go. Here we go. All right, so what we have just done is we've created a new variable. It's called tgroup. This is the one that we wanted. And what tgroup has done, what I did here when I created this variable tgroup, is that I initially set all of the values of tgroup to equal 1. All right, now that's not very helpful. But then I went and I replaced tgroup. I said, all right, now let tgroup equal 0 if ordering is less than, all right, then I have this expression here, underscore n divided by 2. So I need to make sense of this. Underscore n divided by 2 means, so the underscore n is the total number of observations in your data set. Underscore n is the total number of observations in your data set. And if you divide that by 2, you will get the number of half of the variable of the observations in your data set. All right, now remember ordering. The ordering variable is the number that tells you the order that this particular observation falls in with respect to the random number that we gave them. Okay, so what I'm saying here is that if the ordering variable is less than the halfway mark, if it's less than the halfway mark in the ordering, then tgroup equals 0. All I've done there, all that I've done or I've accomplished with that code is that I've basically said that a random sample of households from our data set have now been assigned to the control group, which means that the other half is assigned to the treatment group. That means we have a randomly assigned control group and a randomly assigned treatment group. The determination of who is in the treatment group and who is in the control group is random. The reason it's random, all right, I think that this process can be somewhat unclear, so I'm going to try to go through it one more time. The first thing that we do is we create some random number. Every single individual in this data set has a different random number. All right. What we ultimately want to do is we want to use this random number as the basis for splitting our sample into two halves, where half of the data set is going to be called the treatment and half of the data set is going to be called the control. Half the data set will be the treatment group, the other half will be the control group. We're going to use the random number as our basis for who falls into the treatment group and who falls into the control group. Because everyone has a different random number, it's entirely random what number each household has, because it's random. So what we can do is we can say, okay, everyone who has a random variable above the middle, the intermediate, the mode of the random variable, whoever has above half, they get called the treatment group, and everyone below that is called the control group. So we're using this random number as a means of assigning our treatment group assignment. All right. The way we do that is by creating this variable called ordering. All right. Now this ordering variable is going to give every single household a number between 1 and 1,129. The person with the smallest random number will be 1. The person with the biggest random number will be 1,129. So it has ranked the random numbers from smallest to largest. Then all I have to do is just say, well, the households that have the random number, or let's say it this way. Half of those households are going to be given the treatment, and half are going to be given the control. And a convenient way to split them in half is just to say that the households have the ordering number from 1 to the halfway mark will be called the control, and then the households from the halfway mark to the to the total 1,129, they are being assigned to the treatment group. And because the ordering is based on these random numbers, then splitting the sample in half like that and assigning the upper half to the treatment and the lower half to the control is randomly assigning the individuals. Okay, that's randomly assigning each household to the treatment group and control group. Okay, I hope that's clear. Let me know if you have any questions on that, kind of why this code accomplishes the random assignment. Just try to follow it through, think it through, and I think you'll see why this code accomplishes the random assignment. Let me know if you have questions. Okay, so that's the first one. So we did practice number 1, household level randomization without stratification. Now we're going to do stratification. All right, practice number 2, household level randomization with stratification. All right, now again, we ultimately want a, oh, you know what I'm going to do real quick first? I'm going to drop the variables we don't need anymore. We don't need random number anymore, and we don't need ordering. So if you want to drop variables, you type drop, that's the command. You list the variables you want to delete, you highlight it, click it, they're gone. All right, now coming over here. We ultimately want a variable called T group, let's going to call it T group 2, treatment group, where T group 2 equals 1 if the household is assigned to the treatment group, and T group 2 is equals 0 if the household is assigned to the control group. But now we will first stratify our data by, let's see, in the homework you're told to stratify by village, but for the purposes of this illustration, I'm going to stratify by something different. I'm going to stratify by something that I think would be interesting to stratify by, and that is V access. So access to a road year round. I'm going to stratify by that. All right, and then you're going to have to stratify by village in your homework. Okay, so what do we want to do here? We're doing basically the same thing, but we just have to do one step first. What we need to do, what we need to do is we need to define, let's see, we already know this, all right. Okay, the first thing we need to do now is we need to define our stratification variable. Okay, we need to define our stratification variable. Now we know that in this case, our stratification variable is going to be V access. All right, that's our stratification variable. Is going to be V access. All right. Now, how do we go from there? Now, once we know what our stratification variable is, then what we need to do is we need to do the same thing we did before, and that is generate our random numbers. So we will do that. We'll generate our random numbers again. All right. But now what we need to do is we need to generate our rankings and assign our groups within the strata. And the way that works is like this. What we do, so I'm going to do this. All right. I'm going to create a variable called strata. I'm going to do egen strata equals group and then V access. And what this command does is it creates a variable called strata that equals 1 for each of the groups labeled by V access. All right, so let's do that. So here's strata. And in this case, in the case of V access, there's only 2 possible groups. There's one, that is households that don't have access to a road year-round, and 2, households that do have access to a road year-round. But if you had a variable that had more than 2 values, so v-access was only 2 values, actually we might want to see that. Let's just take a look and see that. Tab v-access. All right. So village is accessible by road all year. So 1 equals, so it's a binary variable, has 2 values. It can take the value of 0 or the value of 1. All right. 186 households in our data set do not have access to a road year-round, and 943 households in our data set do have access to a road year-round. Okay, so it's a binary variable. We could have other variables, like let's tab village and just see what that looks like. There's a lot of different villages. There's a lot of different villages here. All right. But that's not what we're working with here. We're working with v-access. Okay, so we did egen strata equals group v-access. So now we have a variable called strata, and it's a categorical variable that labels the group. So it labels the group, or it labels the different strata. So now what we want to do is we want to do a command called bysort. And what this basically means is that we are going to perform each of the commands that we did before, but this time we're going to do them within the different strata. Okay, because that's what stratification is. What stratification is when you do the random assignment of your treatment, so your treatment group assignment, you do that random assignment within subgroups. So up here before, we did the random assignment for the whole sample data set. Down here, what we're going to do is we're going to do the random assignment within each of the subgroups, or within each of the strata. In this case, we have 2 strata. We have the people that have access to a road and the people that don't. Now, within the group of people that have access to the road, we're going to do our random assignment. And then within the group of people that don't have access to a road, we're going to do our random assignment. And the way that we do that in Stata is we create our strata variable. That's what we've done here. Then we're going to use this bysort command. And what this means is that whatever command you give after it will be performed within each of the groups that you identify with your bysort. We're going to do bysort strata. So within each of the groups of the strata variable. All right, so let's do that. I'm just going to click all this and go. So now we've done our ordering. All right, we've done our ordering, and we have assigned our treatment group. All right, so we've done our ordering, and we have assigned our treatment group within the strata. Okay, I hope that is clear. Please let me know if you have any questions. The last thing that we're going to do is we're going to perform a balancing test. Practice number 3. We're going to do a balancing test. Do balancing test. All right. So a balancing test. What a balancing test is it's a series of t-tests. Okay, a series of t-tests looking at the mean difference for a variable between 2 groups. So what this would mean would be you're looking at the average age for people that are in the treatment group and comparing it to the average age of people in the control group. And what the t-test does is allows you to know whether or not the difference that you observe between those two means is statistically significant. And if it's statistically significant, that would be evidence that our randomization did not achieve statistical independence. We want to see that the means are the same between the treatment group and the control group. We want to see that the means are the same between the treatment group and the control group. Okay, and so we want to see that the mean, whatever the mean difference is not statistically significant. So let's use one example, and then I'm going to go through and show you more. So what we want to do, okay, just one more quick point. Ultimately, what we're getting at here is that if we have done a random assignment, we want to know, if we've done a random assignment, we want to know that our treatment group is the same on average as our control group. The way that we do that is we compare the average value for the different variables between the treatment group and the control group. And if they are the same, that would be evidence that our treatment group and our control group are the same on average. If they are not the same, that means if they are statistically significantly different from each other, that would suggest that we do not have statistical independence. All right, now let's do a t-test and let's illustrate what that means. What I'm going to do is t-test age head. So I'm going to look at the average age for people in the treatment group versus people in the control group. So do t-test age head, that's the variable I'm looking at, by, and then I want to do the T group 2. So what this will do is it will show me the average age for people that have been assigned to the treatment group. So that is where T group 2 equals 1. And the average age for people that have been assigned to the control group, that is where T group 2 equals 0. That'll show me the difference, and then it will show me the statistical significance. We want to see that it's not statistically significant. But okay, let's highlight this. And let's show it. Oh, sometimes it looks a little goofy if I have this window up too big, so let's do it again. There it is. So here's our output results. How do we read this? Well, let's take a look. What we have here is the different groups. So it's called group. What that means is these are the different values of the variable T group. So this is if T group equals 0. That means someone that has been assigned to the control. And then 1 here, that means T group 2 equals 1. And if T group 2 equals 1, that means they've been assigned to the treatment group. All right. And so now, then we go across, and we've got some descriptive statistics. We've got the number of people assigned to the control group, 563. We've got the number of people assigned to the treatment group, that's 566. And then we have the averages, okay? So the average age for the people assigned to the control group is 46. 46.2, let's say. And the average age for the people assigned to the treatment group is 45.8. All right, now they're a little bit different from each other. We can see the difference if we come down here. It's called diff. The difference between them is 0.34, 0.35. All right, so there is a difference in the average age between these two groups of people, between the treatment group and the control group. But now the question is that difference statistically significant? Do we have any reason to think that that difference is a reflection of the idea that the treatment group is actually different than the control group? We come down here to figure that out by looking at our p-value. That's down here. This is our p-value. Our p-value tells us the probability of observing a difference at least as large as this if, in fact, there is no difference between the treatment and control group. Okay? And we would conclude that there's a statistically significant difference if the p-value is smaller than 0.1 or 0.05 or 0.01. Okay, so if we look here, we'll see that the p-value is 0.645. That means this is not statistically significant. I do not have evidence to think that there is actually a difference between the average age of the treatment group and the average age of the control group. Okay, but now if this was smaller, let's say this was 0.001. That would mean I would conclude that it is significant, and it's significant at the what we call 1% level, and I would give that 3 stars on my my table. Okay, but for this one, there's no difference. That's a good sign for us. That's a good sign for us. That means that our treatment assignment balances on age. That means the age is balanced. The age is the same between the treatment and control group. All right, that's good. But now let's look at some other variables. We have to have more. When we're doing a balancing test, what we do is we just do this same procedure a bunch of times for different variables. So let's do gender, and then we will do education of the household head, and let's do family size, and let's do HH land, so household land ownership, and let's do HH assets, so the household's assets. All right, let's do them one by one. All right, this one, we've got the percentage of the control group that is male is 90%. The percentage of the treatment group that is male is also 90%. The difference is very small, and it's not statistically significant. All right, it balances on the gender variable. Let's do the next one. Education. All right, the average number of years of education in the control group is 2.2. The average number of years of education for the treatment group is 2.4. The difference is pretty small. We find that it is not statistically significant. Good. Our samples balance on the education variable. Let's try another one. These are good signs. This means that our treatment group is the same as our control group with respect to age, gender, and education. But let's look at family size. All right. The control group has on average 5.2 members in the household, and the treatment group has on average 5.4 members in the household. It's a pretty small difference, okay, and it's not statistically significant. All right, so now our sample balances on family size. Our treatment control group are the same on average with respect to family size. We keep doing this for a bunch of variables, and if a bunch of variables show that there's no statistically significant difference, then we begin to conclude that we have statistical independence. But let's keep going. 4 is not enough variables. Let's do it. In your homework, I'm going to have you do 10. In our illustration here, we'll do maybe just a couple more. All right, land size. The control group on average has 68.8 decimals of land. The treatment group on average has 84.8 decimals of land. That seems like kind of a larger difference, but is it statistically significant? Let's look down here. No. The p-value is 0.18. It's still not statistically significant. All right, let's do the next one. Household assets. All right, so we look at household assets, and what do we find? Okay, here's their average for the control group, average for the treatment group, the difference, but again, it's not statistically significant. So our sample is looking pretty good. It's pretty well balanced. Let's see if we can find a variable that is not balanced. Let's see. All right, I'm going to make a point here. The most important variable that you want to make sure that your treatment group and your control group balance over is the outcome variable. So total expenditure. All right, let's look at that one next. T group 2. All right, this is the most important one. Why is that? Before I run this, why is it so important that your treatment group has the same outcome variable on average as your control group before you've implemented your intervention? The reason is because after you have implemented your intervention, what you are going to do is you're going to compare your outcome variable between your treatment group and your control group. And you want to be able to say that whatever difference you observe between your treatment group and your control group is a result of the intervention. But if your treatment group and your control group are already different from each other with respect to the outcome variable, then you will not be able to conclude that the difference that you observe after you've implemented the intervention is a result of the intervention or it's a result of a pre-existing difference. All right, so this is the most important one. You want to be sure it balances on this variable. So let's do this one. All right, what do we've got? Our average total expenditure for the control group, average total expenditure for the treatment group, and it's not statistically significant. Okay, good, they balance there too. Like I said, you're going to want to do 10 variables, at least 10 variables, as long as you have 10 variables available. All right, let's do v-access. Actually, we stratified by that variable, so with it, we don't balance on variable we stratified by. All right, PCIRR. Let's do that. By T group 2. All right, let's see if the access to irrigation is the same between the groups. All right, again, it's the same. What else we got here? Ttest rice. This is the price of rice. By T group 2. All right, let's see. Let's do this one. Aha, okay. Now, things were looking pretty good for a while. Let's see, how many variables did we do? We did 1, 2, 3, 4, 5, 6, 7, 8. We did 8 variables. Now we're on our 9th variable. And what do we see? We've got the average price of rice for the control group is 10.3. The average price of rice for the treatment group is 10.2. The difference is, again, pretty small, but if we come down here, what do we find? We find that it's actually statistically significant. The difference is statistically significant. Now, at what level? Let's see. Our p-value is smaller than 0.1. That means it's significant at the 10% level. It's bigger than 0.05. That means that it is not significant at the 5% level. So it's significant at the 10% level. Okay. All right. That's not too bad. Let's see what happens next. Let's do one more. All right. We're going to do 10. I think I said earlier we weren't going to do 10. We're going to do 10. All right. T-test. Let's do one more egg. So this will be egg prices. By T group 2. All right. Let's do that. All right. Here's our mean. Mean. Difference is very small. P-value very large. Okay. Not statistically significant. All right, so then we can go through this and we can say, okay, here we go. We've got 10 variables. We've done our t-test for 10 variables, and for every single one of them except for one, except for the rice price, for every single one of them, it was not statistically significant. All right, so basically what did we find? We found that one variable out of 10 was statistically significant. All right, and one variable out of 10 was statistically significant at the 10% level. That's what we see here for the rice variable. Significant at the 10% level. That means the p-value is smaller than 0.1 but greater than 0.05. Okay, so 1 out of 10, one variable out of 10 is statistically significant at the 10% level. So then we're going to have to ask ourselves, do we say that this sample has statistical independence? Do we have evidence to suggest that this sample, that this particular randomization has achieved statistical independence? I would say that based on the results of this balancing test, that means these t-tests on 10 different variables, I would say that based on this result, the answer is yes. I think we have strong evidence for statistical independence based on this balancing test. And the reason that I say that is because the typical threshold for balance is that no more than 1 out of 10 variables will be statistically significant at the 10% level. That's the threshold. Now, in this example, I have 1 out of 10 variables that is significant at the 10% level. That means we are right at the threshold. That means we will still conclude that we've achieved statistical independence. If I had another variable that was that had a statistically significant difference at the 10% level, then I would say we didn't have statistical independence. If I had a variable that was statistically significant at the if I did one of these t-tests and I found that for one variable the difference was significant at the 5% level or the 1% level, then I would conclude that I did not have statistical independence. Okay, so a good threshold, a good rule of thumb, it's not perfect, but a good rule of thumb is that 1 out of 10 variables should not, you should see no more than 1 out of 10 variables significant at the 10% level. All right, so that concludes this video. I hope that, one more thing. In my case here, when I stratified by v-axis, I found that this randomization achieves statistical independence. At least I have evidence that it does. And so I would keep this randomization. I would be done. At this point, I'd be done. I would use this randomization, and I would give the people that were assigned to the treatment group, I would give them the treatment, I would give them the intervention, and the ones assigned to the control, I would not give them the intervention. But now if you're doing this and you find that it does not balance, that means one variable is significant at a 5 or a 10 at a 1 or at a 5 or a 1% level, or you find that more than one variable is significant at a 10% level or more, then what you would need to do is re-randomize. You would re-randomize, you would redo your randomization. So I just want to tell you how you would do that. How do you re-randomize in Stata? Well, what you would do is you would come up here. First, you would drop. So I'm just going to do this. All right, re-randomize. All right, you would drop the variables that you don't need. All right, I don't need the variable ordering. Okay, and I don't need the variable random. All right, I'm going to drop those variables. Okay, and then I'm going to copy and paste this. I'm going to entirely redo it. I'm going to entirely redo everything I just did, but I'm going to change the seed. 2, 3, 4, 5, 6, 7, or whatever. All right, I'm going to change the seed. What changing the seed does is it will generate for you a different set of random numbers. All right, and then I'm going to come down here and I'm going to generate a, let's see, what am I missing here? Okay, here it is. I'm going to call it T group 3 and T group 3. Okay, so I'm going to generate a whole nother randomization. And then I'm going to redo the balancing test. All right, so I'm going to take my t-tests, come up here. All right, put those down here, change all these 2s to 3s. All right, I'm going to change all the 2s to 3s, and I'll just redo the whole thing. I'll redo the whole thing, and when we redo it, we're going to have a different random assignment. Different people are going to be assigned to treatment and control, and we will redo our balancing test to see whether or not now we have achieved balance. All right, so that is the Stata tutorial for randomization. This is to help you to supplement your homework, to help you to be able to achieve the assignment 1, part 1. So Stata tutorial randomization for assignment 1, part 1. All right, and you will be able to find that on Blackboard. All right, this data code. All right, thank you so much. I hope you have a great day. Bye.